So hi, thanks for that. My name is Noah Kriegel. I work for ThoughtWorks. We're here in Atlanta. Oh. Hey, Randy. Another thought worker back there, making sure I do this right. So yeah, today I'm going to talk a little bit about the Java 8 Lambda expressions and the Streams API. Full disclosure, just to set expectations and to sort of corral you into this with me. When I suggested I would do this talk a few months ago, I was starting a project that was going to use these things. So I had all sorts of really cool anecdotes to be able to talk to you about and show you like things, and it didn't happen. So please ask me questions. Let's make this take a little bit longer than maybe it could otherwise. Anyone used any of the Streams API or Lambda expressions yet in anger? In anger, like when you were getting paid. Oh, yeah. All right, cool. Anyone else? Anyone? All right, well, I haven't, so keep me honest. All right, so the basic idea of Lambda expressions. Everyone who knows what I'm talking about when I say Lambda expressions, please say. Okay, so half. That's pretty good. So Lambda expressions are a bit of a religious topic, and I am not going to stand here and debate whether or not they exist in Java yet. So you can go online, you can look up exactly what the abstract algebraic definition of a Lambda expression is. We don't have those. What we do have is methods as data. So this has actually been coming for a while. They started to prepare for it in Java 7 when they gave us functional interface. Well, they called them SAMs. But the idea now is that in Java 8, you can, if you wish, package up a method, set it to a variable, and send it in to another method, so that the functionality encoded in that method could then be used at some later time in some algorithm. Does that make sense? Lambda expressions. Before we talk about Lambda expressions, though, we have to talk about functional interfaces, because this is how Java, or Oracle, or whoever you want to call them these days, was able to give us Lambda type things. I'm going to stop saying Lambda type things now. I'm just going to call them Lambda expressions from now on. Anyone who disagrees that this is what they are, don't argue with me about it. So a functional interface is really nothing more than an interface, just a regular Java interface. The difference is that it only has a single method declared on it. Well, I should say a single abstract method declared on it. There are a couple of other possibilities. You could have default methods, which are also a new feature of Java 8. So you can have an interface that defines the implementation of a method so that other implementing classes don't have to. Those can exist on functional interfaces. Also, and I kind of wonder if this wasn't just an accident, you can have declared on your functional interface any method that object declares, because you're going to be implementing it anyway, so it's okay. I still think that was an accident. They say it like it's a feature. Seems accidental to me. I wouldn't call equals on a Lambda expression. I really have no idea what it'll do. You may have heard of functional interfaces in the past. People used to refer to them as SAMs, single abstract method interfaces. An example? Runnable, or action listener, comparator. All of these haven't really changed from Java 7 till now, but all of these are examples of functional interfaces. Runnable takes a single method with no parameters. Action listener requires that you implement a single method with one parameter. Comparator, a single method with two parameters. Come on in. You're not late. I just started. It's cool. There's a chair up here. There's one over there too. No? Stay in the back? Okay, that's cool. Y'all ever see the Blue Man Group? Anyone ever see the Blue Man Group? People come in late for the Blue Man Group. They actually have these big air raid lights. They like turn on and shine on you as you come down the hallway. It's really kind of fun. They stop the whole show. You should go see it. It's fun. Anyway, the point is, anywhere we use a functional interface, we can now use these interfaces as a target for Lambda expressions. So if I want to have a variable of type runnable, I'm sorry, when I started, I asked people to ask me questions. Every time I hear someone's voice, I think I'm getting asked a question. So if we have a variable of type runnable, we can set now not just an actual instance, an implementing instance, but we could set a method that would do something if someone were to use it later. Does that sort of make sense? We could also pass these into the expression. Oh, sorry, and I almost forgot. We have a brand new annotation that does nothing except for mark your code so you know what you're doing. Functional interface. Has no actual use. So the neat thing about functional interfaces is we can create our own, right? I mean, we don't have to use one that's already there. For instance, I created this interface called calc. It declares a single method, calculate, takes 2 integers. Nothing to it. In the doesCalc method, I take an instance of calc. And I've stuck in here some actual values because I didn't really want to write silly code to make arbitrary numbers pop up. In the past, in Java 7, we may have used an anonymous inner class to fulfill this method. So we could have done something like this. So we create our new functional interfaces class up here. We say, OK, our answer is that thing does calc, and then we just say new calc, right? Anonymous inner class, we're all, this is AJUG, right? I don't have to talk about anonymous inner classes, right? OK, good. And so we have a little test that'll run. Well, I'm not going to pop over to Eclipse to run. Take my word for it, it'll run, and it'll return a plus b, and the answer will be 8. So the first thing they've given us with Lambda expressions is just some syntactic sugar, because honestly, anonymous inner classes stink. Right? They're ugly. They block up your code. You can rewrite it much more nicely with a Lambda expression. So you'll notice that doesCalc takes an instance of calc. And here I'm calling doesCalc, and I haven't actually given it an instance of anything. I've given it an expression, a Lambda expression. The expression is in 2 parts. Your parameters. I tend to call this the rocket because I've done a lot of Ruby. I don't know exactly what they're calling it. And then either an expression, a statement, or a set of statements. In this case, we simply say that our calc method will take some function that takes 2 ints, and then return their sum. Of course, I could put in a subtraction operator here. I can do whatever I like. Is that clear enough? You're really going to have to ask me questions, because without like the actual experience of using this, I don't have any good stories to tell yet. So there are a couple of different ways you can write a Lambda expression. The first one we just saw, we had the parameters and we had some statements in a block. You can also simply give it a single expression. And then you can, if you wish, and I think it makes cleaner code, simply infer your parameter types. I didn't actually have to write int. So a couple of different ways I could do this. And excuse me, this isn't actually code that can compile. I just figured. So we have our original doesCalc with the ints and the returns x, y in a block. I could take them out, just say x, y, and return the block. I could even replace this with an expression. If I were writing the code, I think I would go with this. Now, you can, of course, in that block, have multiple statements with the return value, right? This is a function, and it can be declared like any other function. So I could say, for instance, I have my integer a is going to be equal to some sort of manipulation with the parameters. Same with b, and then I could add a and b together instead of x and y. It'd be 34, but that's sort of a trivial thing. Does that make sense to everyone? And of course, you're not held to my inline thing here. Again, maybe it's just too many years doing Ruby. I like to string as much as I can on a single line. But of course, you can have that come down, just like the implementation of an anonymous inner class method. Of course, then you just get all this ugly cruft again, and I don't know what you're buying yourself. The one thing to remember, though, is that the compiler really does care about your Lambda expressions. In fact, it's working very hard when you tell it, here's my Lambda expression, to figure out just exactly what you mean. So while you don't have to state that your parameters are ints, and you don't have to have brackets, and you can just have some expression. If you try to do something that's illegal, this will become a compile time error. So here I've said, here's my x and y, and call concat from x to y, the compiler will catch that and won't let you. Because it's figured out that calc takes a functional interface, and this doesn't match that functional interface. Fantastic. What can I do for you? Yes, it will autobox. So if this was integer, and I passed in 3 and 5 and x and y, it would figure that out just fine. You have any other questions? I'd really love some questions.
So if you implement a functional interface, does it generate an abstract class around it, or does it do not an abstract class, but an anonymous inner class around the function, or does it generate?
So that's interesting. I wish I could bring that up. I don't know how to do it. So I've seen the stack traces, and sort of, but not really. So it's not exactly an anonymous inner class in that if you had an anonymous inner class, every time you ran into it, you would have another one, right? You'd have a new instance of it. In the case of a Lambda expression, if every time you run into it, well, this is sort of the same class. So if I called this method multiple times and it broke, you'd actually see the same class being invoked both times. But it is just an object. But it's one object. And I'm not exactly sure what the trick it is they use to make it essentially a singleton. There you go. Invoke dynamic. That makes sense. Oh, a gotcha question. That's even worse, man. Come on, I thought you were helping me out here.
I was.
Man, I'm glad I figured out the right answer to that question when I asked it. Ooh. All right, tough crowd. Wow. Thank you, though.
If we step in the debugger into that, if you have multiple statements there in your brackets, if you step in, would it step in that order? Or
Yeah. If you break inside your function, it'll go in, yeah. It's just, the stack does get a bit messy, actually, with the Lambda expressions, but it's not too hard to figure out. The functional interface can only have one abstract method declared. Right, so the new default methods that are out in Java 8, where you can actually have your interface define an implementation of the method, you can have as many of those as you want, and you can have anything that object has, which, like I said before, I think was an accident, but because I don't know how else they do it, right? It's an object. It's got the object methods. All right, where am I going here? Time error. And then, of course, it's also possible to call a Lambda expression. So remember, it's just like a function. Sometimes you just won't have parameters. All right, so for instance, if you're going to do a runnable, this is what runnable or a new thread would look like if you had a runnable anonymous class, anonymous inner class, right? Instead here, you can just have an empty set of parens indicating we have no parameters to give. And then here again, we have just an expression, right? So no block, just single expression. Clear? Good. So it's an interesting thing, right? We have these targets for Lambda expressions. These targets are places in our code where we've declared a functional interface is going to be used, either in a method declaration for a parameter or in the declaration of a variable. But it might make sense to you if you think about it that the compiler knows what other things could go into this space. Yeah? Even if you don't use a Lambda expression or anonymous inner class, there are other methods out there in your library that could be used. So you can, if you want, use method references, as long as those methods actually do implement the functional interface. Does that make sense? So for instance, in this case, in my little sort array method here, if I have an array of integers, and then I can say array sort, pass in my array of integers, and I can simply declare that I want to use the integers comparator. Right, without saying anything else. It's not actually a Lambda expression, it's a method reference. And you can do this for static or instance methods. If you do it for an instance method, well, if you do it for a static method like you do here, which is probably the most common use case, if you break that, you're going to have to pay for it. The static method is probably the most common use case, and what happens is on integer, compare will be called, and the element will be passed into it. If instead you had called an instance method, it would be the same syntax. Integer, I can't think of an instance method off the top of my head, but pick one. And instead that would be called on the element that was being passed in. Does that make sense? So as we sort, I guess we're passing two integers into the comparator. So every pair will be passed in to integer.compare.
So what's the first one? The second one is an instance, right? What's the first one again?
Well, no, this is, I was just pointing out that compare is a static method. So this syntax is completely equivalent to this syntax, and in fact, the compiler, will rewrite this into this. So if you actually look at your bytecode, you end up with the same stuff. Right? It's just that in this case, the pair of ints that will be passed in will be passed to the compare method on integer. If you had a single parameter method, but it was an instance method, that method would be called on. Sorry, if you had a no parameter method, it was an instance method, that method would be called on the element that was being passed in. And in the case where you had two, what you'd end up with is parameter one dot method, and then parameter two passed into that method. Does that make sense? I probably should have written that one out. So method references are great because if you think about it, when you go through a lot of the, especially the collections API where this is going to be used a lot, as you go through, most of the things we want to do are generally written for us already. So method references make it nice and clean to sort of declaratively indicate what we want the code to do. Make it very readable, I find. Any other questions? 7:30, man. Normally going fast is good, but okay. So you're not on your own. When you're creating Lambda expressions like we did earlier, you can create a functional interface of your own if you like. But also in Java 8, we have the new package Java util function that contains a whole bunch of functional interfaces that are already declared for us. They're, of course, used as target. My slides are getting repetitive. I mark that down. They're used as target types for Lambda expressions, and they're used extensively by the JDK. So if you're ever looking through like the collections API or a number of the new classes that are using Lambda expressions or functional interfaces, keep an eye on the Java docs for the util function package because all of them will be in there. A couple of them I put here on this slide to give you an idea. The four main ones, there's actually one other that I didn't put here. I can't remember what it is right now. The four main ones are, so functions. So functions are fairly simple. A function will be passed in an object, or I'm sorry, a parameter, and will pass you out a different parameter. I mean, they don't have to. I guess they could stick out the same one, but then what's the point? There are consumers, which take in a parameter and return void. There are predicates, which are essentially tests to see whether or not the parameter that got passed in passes some logical test. They will return to you true or false. And then finally, there are suppliers. And suppliers are useful if you have a parameter that goes in, say, okay, so I have a whole bunch of stuff, I'm going to send something in, and out of that, I want to create something new. So the supplier will return you a new object. On all of these, in the package, they have the arity modifier. So these are essentially arity of 1 as they stand. All of these have at least arity 2 representations in the package already. So there's a buy function, a buy consumer, a buy supplier, and a buy predicate. And all that means is that the buy function takes 2 inputs and returns you an output. and the buy consumer consumes a pair of input, so on and so forth. Also in that in that package we have specializations. There are a ton of them, too long to list. There might be, I don't know, 15, maybe 20 of them. Things like double to int function, which does exactly what you think it was, takes a double, returns you an int. Or the long consumer, which is the consumer that takes a long and does nothing. And there are a whole bunch of those for most of the primitive types and most of the primitive type combinations. Did I say it wrong when I was talking? I probably did. Believe what's on the slide. I lied. Yes, I'm sorry. If I said that, I apologize. What the supplier does essentially create something new. All right, so you can pass in. It's pretty good for. I gotta start marking these notes down if I ever have to do this again. It's pretty good for strategy functions. So if you have sort of like a strategy design pattern going on, you can have a handful of suppliers where, depending on what's going on with the state of your code at any given time, you can decide which supplier to use in an algorithm, and so it'll create a new instance of something. And then you can go on and use that new instance. All right, but the code that's actually implementing that algorithm won't have to know anything about how the internals of that particular object. Does that make sense? Vaguely, yeah.
So arity, that's the number and type of arguments in the return type, right?
Mm-hmm.
So can you briefly explain again what the point of the modifier is?
Oh, the arity modifier. I'm sorry, it's not really a modifier. It's a modifier of the name. So we have consumer and we have by consumer. That's the two arity of consumer. We have by function. Well, you could. They didn't. They only went up to buy. So. But yeah, in theory, you could build your own.
Useful in implementing a reduce, where you kind of like what you did before, where you were earlier when you had a function that took two arguments and returned.
Yeah. So if you get into the streams API, there's actually there's a collections or collectors.reduce that takes a by function. So it'll pass in a pair of things, and you'll stick one out, and then it'll. Oh yeah, no doubt. Right, no doubt. The arity model. Well, I mean, the primitive ones. I don't know if they had a use for all of them, but I think what they found was there was some performance benefits to having specialized primitive types. But yeah, no, there's no doubt that the basic shapes they have for the function declarations, and then the arity2 set was because the collections and the streams API is going to use these things somewhat extensively.
So the byte predicate, is it an AND or an OR? So I'm assuming for a byte predicate, I give two predicates.
Okay. Oh, the by predicate. Sorry. It takes two arguments and returns a Boolean. So the predicate, these three, right, they take whatever it is that you give them, right, whatever parameters they've been declared to have. So in the example I gave, they were ints, but they could be objects of any type. The difference is in what they return. Right, so a consumer returns nothing, it just does something, or does nothing. But the idea is it does something, like log, for instance.
The point of this slide is just that they provided some interfaces for you, and you can write the code to implement.
Yeah. Right, I guess what you're going to find across the API is that there's a whole bunch of this being used already, and this is mainly where the new cool functional interfaces can be found. I just wanted to introduce you to the basic types. Okay. So I did have an example of by function. And what I did here was I just wanted to point out that you can have a Lambda expression set to a variable if you want. So in, say, map merge, for instance. So map merge, essentially what map merge does is if you have a map and you say map merge this key with this value, it'll check to see whether or not the key exists, or if it's set to null. If it doesn't, it'll set it to the value. If it does, it'll perform whatever method you want it to perform. Where am I looking? Sorry, I'm too close now. Your third parameter that you send in is the thing you want it to do. And what you pass into the third thing is the value that's there currently and the value that you have declared as your second parameter in the merge. Does that make sense? Am I just talking over myself? Yeah. Map merge in HashMap is one of the new collection, merge in HashMap is one of the new collection methods that makes use of Lambda expressions, or well, functional interfaces really. What it does is if you have a hash map, so in my case I have a hash map declared with keys and values of both strings to keep things simple. So if I say merge some string, some other string, and then the third parameter here is declared as a functional interface. So it is a target then for a Lambda expression. What it'll do is it'll look into this hash map and say, does this key exist? If it doesn't, set it equal to this value, insert and set it equal to this value. If it does, do whatever this functionality describes with this as one parameter and the current value as the other. So in my example, I just said, okay, well, we'll just concat, right? So if it's there already, I'll just concat string 1, string 2 together, and that'll be the new value of the key. And this is just to list out 3 completely equivalent ways of doing that. I can set my Lambda expression to an instance of a variable, and then I can use that variable in my method call. I can have a raw Lambda, well, I shouldn't say raw, it's just a Lambda expression. I can just have a Lambda expression in there. That's the same thing I set equal to concat earlier. Or in this case, again, since I just called the string concat method, I can make reference directly to that method without actually using a Lambda expression at all. Since concat already exists and it matches the functional interface for the third parameter to this method, I can just refer to it. Now before, when we looked at integer, we had a static method. This is an instance method. So concat is an instance method on string. And it does exactly what you think it would do. So on the first parameter that will get passed, the method will be called on. And the second parameter, the method will be called as a parameter. Right. The first string will have this method called onIt, and the second string will be the input to that method.
How do we know which is the first parameter versus which is the second? Is the new value the second parameter, the existing value for the key the first parameter, or is it the other way around?
The only way you know, well, obviously in this case, right, you know for sure. When you use the method reference, the only way you know is because you have read the Java doc for that particular method call. Because what's happening inside merge is they're taking concat and they're calling it.
Yeah, in your count method, you hard-coded the values to range 5.
Yeah.
Can the Java Lambda functions look at free variables that are in the context?
Yes. Okay. Yes, but. Or yes, and. I'm a consultant. I say yes, and. Yes, and you should be careful. Right. So this is an interesting point, and I was actually debating with myself whether or not to bring it up, and I had actually decided not to, but since you mentioned it, I will. Lambdas are in fact closures. Some of you probably already knew that. I hesitate to bring it up because closures, in my personal opinion, are terribly dangerous things. So in fact, yes, the Lambda expression is closed over the locally scoped variables with some exceptions. It's closed over the locally scoped variables that are either part of the class in which the Lambda expression appears or are effectively final. And effectively final means either declare it as final or the compiler agrees with you and says, yeah, okay, that's cool, no one's going to change it. Does that make sense? So you can, if you want, refer to the local fields of your class, or the instance of the object in which you've been declared. You can refer to those methods. And in fact, you can refer to this and super. And the this and the super inside your Lambda, don't do this. Don't do this. But the this and the super in your Lambda expression will be referring to the outer this and super. So if you have, what did I have? I forget what my class is called, functional interface. And inside there, I said my Lambda expression for where I send in for the calc method. If I had a block, and in that block I called super, it would call functional interfaces, parent, whatever. There are definitely people who are smarter than me in this world, and they might have a really good reason for doing this. I cannot think of a reason that you would take on that kind of strange complexity in your code base. So if you do it, don't blame it on me and don't blame AJUG, okay?
You have a variable right below the hash map declaration. Right below that, if you have string s equal to hello,
Sure.
can I reference that inside my Lambda expression?
In this specific case, maybe. I think if I'm doing static analysis correct in my head, that would be effectively final because nobody else would touch it. But you can't mess with it because then it's not effectively final, and then the compiler will yell at you. So if you had static final string or just final string.
So I cannot change the state of that variable and reference it down below?
Well, it depends what you mean by below. So if you had here
Right,
string x equals foo,
right. And in my change, I'll change foo to bar inside my Lambda expression.
inside here,
Correct. Change that foo to bar. What will be the status of the variable before the flowery bracket?
you still have your thing up? I'm pretty sure that's a syntax error because I am pretty sure that that local variable has to be final. Now, what you could do is whatever class this is actually in, let's say it had a field, you can modify that field. But the local variable will have to be effectively final before you're allowed to use it inside your Lambda expression.
How can I have access to the field? Because you said this will refer to the functional interface of that guy. How do you access the field?
Don't look ahead. This is my little playground, so don't. So what I could do, let's say, here. All right, so I'm in this class, functional interfaces. And then let's say I have in here, something like that. Huh? So now I'm inside my method declaration. You might be right. I don't think so. Will do.
I bet it's going to be low.
Try to
You can try to
include
modify
that.
after that one.
Yeah.
After start.
You want to?
Because this is effective.
Append is not a method in string. It's a method in string buffer.
Yeah, right.
You can.
So I don't. Well, I take it all back.
Well, strings are
Oh, strings are immutable.
Yeah, that's just going to
They're effectively final. Come on, okay, fine. I'm fine. Yep.
So after you call start. On the new line after start.
This isn't a good test because it's creating a thread.
You'd want something that was not threading.
Well, it should be a
Well,
compile error.
it shouldn't
anyway.
make a difference, right? So, I don't know what to make of that.
So now we need object.
No, I think it's Eclipse being weird because I just put together a stupid bit of code and I'm getting a compile error.
Oh, good.
Yeah.
That makes me feel better. So,
See if it runs.
yeah, of course they don't actually have a test for that. What's the?
Or save it and see if it gives you the red line of doom. It should force a compile.
No, I've got a whole bunch of crap down here.
Oh.
It's just
Oh, so that might also be something else that's throwing a compiler.
that's a good point. See, I was all excited to actually get to some code, and I forgot that all this is just messed up. Oh. Ah, fantastic. You're absolutely right. Thank you. I wasn't lying to you. Right. So, I mean, you could. I mean, right? Problem now is, okay, so I can't do that or that. Right? But I could refer to it. I could use it for something.
But you can't modify.
Well, I can't modify it because it's final.
Right.
And I can't use it if it's not.
Which makes sense.
Yeah. Right. But
So this is not a trick to return multiple things out of the function.
this is not a trick to return multiple. Dude, who said that?
But that is when you see them for the first time, you're thinking, wow, I can mess with the scope outside of.
Right, yeah, you could have all sorts of side effects.
I'm not saying it was a good idea.
You didn't say I should fry my shirt, you said I could fry my shirt. So yeah. Any other questions? Well, I got the code open.
Yeah, could you just go to the, where, run is defined
We're runnable? This is my runnable right here. Might be easier if I bring it all back up on the one. Oops. It'd be easier if I do that without having anything highlighted. And I can actually separate that out. It makes it easier to see. Okay. Does that make sense? So that is the Lambda expression for the runnable. Now remember, you don't have to actually say it's a runnable. You just have to make it so that it can fit into whatever this method that you're calling. In this case, the constructor thread inspection. Okay? Cool.
Can the lambda expression, can that be like, what if I took that S1 comma S2, that thing, and let's say I make a string from that, and then pass that string. Will that be interpreted as a lambda expression?
I'm not sure I understand what you mean.
Okay, take out the S1 comma S2, the second, the one in the middle. The one in, no, come down. Yeah, let's say I put that in a string.
How would you do that?
You mean you actually
String
pass
S
a string literal here?
No, string S equal to that whole thing, this parentheses all the way to the end.
So you have like
You want a string equal to the
whole thing, the whole thing.
No.
You can't pass.
This, if it's any, this is of a type. In this particular case, in the case of this merge, the type of this expression has to be inferred by the compiler. But if we were to declare it specifically, it would look like this. So the type of this expression is a bifunction with a 3-string generic thing underneath.
It's not JavaScript or even some ugly Perl. where you can pass
That's what I
a
was
string
getting
and
to.
say, execute the string.
Yeah, that's what I was getting to.
No, no, it's not arbitrary execution. It is essentially it's a function declaration and a method declaration. It's just a syntactic sugar. Did I say that already? For a method declaration. You could take concat and call it, right? Because we know concat implements the bifunction interface. So once I set my lambda expression to a variable, I could just say concat.apply and pass it two strings. Right, so I haven't told you this yet, but if you look at the bifunction interface, I'm like 90% sure the method's called apply. Doesn't really come up, right? Because you don't ever actually override it, or implement it, I should say.
Kind of correlating to that, did you serialize your concat and then deserialize it and call it?
Could you serialize your concat?
So now it's a variable. Do you pass it from server to client?
Oh, I mean, could you serialize concat?
Yeah.
Yeah, sure. It's just an object, right? I mean, literally, there's an object in there, there's an instance object in there that has a method called apply that will do s1 concat s2 with two string variables being sent into it. It also actually has a handful of other methods declared on it if you were actually to sort of inspect it in a debugger, because the bifunction interface actually declares a handful of default methods to help you out.
Does it implement serializable?
Oh, does it implement serializable? Oh, that's a good point. Probably not. I don't know. But yeah, I mean, there's no theoretical reason why you couldn't actually make it serializable and just yeah. You're right. I'm sorry. You could probably declare serializable by function override. It extends by function. Implement serializable. You know what I'm trying to say?
Yeah.
So with this functional programming capability, you're moving.
I like that you called it that.
Was that?
Not for the complete there yet, but sure, I'll go with you.
Like that's where it's moving, right?
That is where we're going at.
What does this buy you in terms of like when you're writing an application, when you're trying to make because you're not going to be doing a completely object-oriented approach anymore, right?
Correct.
So what cases have you found?
Oh, it depends what you call object-oriented approach. I'd say most traditionalists would say no. Some people would argue that JavaScript is perhaps the most fully object-oriented language that we have. Well, I mean, there's small talk on all that stuff too. And someone's going to say, I said it before anyone else, right? I said small talk before you did. All right. And the fact of the matter is functions in that language are just objects. Right. So functionalize a style, perhaps, is what you're asking. So, I mean, right now, if nothing else, we clean up a whole bunch of code. We also have a bunch more fluent APIs on a number of library objects. And we also have the ability, well, you'll see in a few minutes, this dovetails very nicely with the Streams API, which gives us some abilities to be very efficient with how we handle large sets of data. Now that I've said that in answer to a question about functional programming, do these things have side effects? Yeah. Do we curry? Well, you could, but it's not really built in. So yeah, Java 8 was not giving you functional Java, but they were giving you lambdas.
So it lets you program Java in a more functional style, you would say?
You could use a more functional style. And you are encouraged to use a more functional style. I mean, the Streams API is very functional. Right? You pass a function into a function into a function, and it spits out a result without modifying the original inputs. We'll get there in a second. But specifically, what they did, if you read some of the documents going back, gosh, 5 or 6 years now, the back and forth about how they were going to implement lambdas / closures in Java had a lot to do with how they were not going to break the potential for future functional programming. So they were, I think, fairly careful not to do that, if that makes sense. And I think a lot of that has to do with the reason that the Lambda expression syntax simply compiles it bytecode into an anonymous a modified anonymous class, right? Instance.
So the new constructs whatever function you're saying, that allow doing something like a fold left or fold right in standard functional language.
Not in the library that I've seen. It's possible it's in there somewhere, but I mean, there's no reason you couldn't write it like that. I don't know. I didn't try. Sorry. I don't see why not, though. I mean, I'm trying to think through it in my head while we're standing here, and I can't think of a good reason why you couldn't do it. It would just take some clever coding, and I'm not a big fan of clever coding. I know I'm supposed to be, right? I work for an IT consultancy. I like clever solutions. The coding, though, gets too clever, and then I just lose the handle on it, and I can't ever figure out. I don't know if I want to force that into Java at this point, but I don't know. Now that you're saying it, like, it doesn't seem that far off. I mean, right? You'd have a buy function that would take, I mean, the buy function is generic, so there's no reason the buy function can't take a parameter in another function, right?
And that should be a fixed value, right? If you take a fold left or fold right.
Well, it would be a fixed value. It would be a fixed value after you process the original input, right? You know, I think the answer is I just don't know. I probably should have stopped talking when I said that. But I'm up here. I feel like I'm supposed to say things. I'm sorry. If you do it, come back and let me know. Okay. Stream API, map, and reduce. I had no idea. So I should tell you that I'm not the best at putting slides together, and our company has just gone through this whole like rebranding effort. So I said, hey, I got to do a slide deck. They're like, okay, well, here's a template. There's actually something supposed to be in the middle of this screen that I erased. And then like it's like title here, and then it literally said, like, I think it said something along the lines of pithy maxim or something. Yeah, I was like, I don't know what to say. I'm supposed to be clever, but like I just said. All right, so streams. So in general, we're good with functional interfaces and Lambda expressions. Yeah? Okay, cool. So the Streams API was built into Java 8 mainly to clean up and help to parallelize the processing of large collections of data. They don't even have to be large, even if they're just a little bit complicated. It cleans it up. Parallelize for the large, clean up for the intricate. So in the package Java util stream, we have a number of classes that are here to initiate, essentially, the Streams API on a given collections class. So there's stream, which is really the only one that you need to use. They also declare in-stream, long-stream, and double-stream, which, like I said, if you're smarter than I am and terribly clever, I'm sure you could use these by hand. But really where you see in-stream, long-stream, and double streams, if you take a stream and you do something to it, and that thing you do to it knows that it's going to produce a whole bunch of ints, it's going to hand you an in-stream, which is just a set of streams. It's not going to tell you, but that's what it's going to do, because there are some efficiencies in the in-stream and the various primitive streams. So in a similar sense to iterators, they have all the values in a, well, I keep on saying collection because my thought process is always about collections and how we can use them. There's no reason, the stream isn't actually backed by anything, right? The data is simply in memory. It can be drawn out of a collection, so an array list or a hash map. It can be drawn out of an IO stream. It can be drawn out of a number of things, I suppose. So on the stream, we have a number of operations defined, and in general, and I put usually here, and that's why I just said in general, but now that I'm standing here thinking about it, I can't remember why I backed off on saying always it's functional interfaces. I can't think of one off the top of my head that isn't. But this is sort of where Lambda expression and the Stream API goes together, where all the operations on stream, in general, will take, well, will have as their target a functional interface, whether or not you want to use anonymous interclasses, Lambda expressions, method references. It's up to you. So in a stream, the operators will manipulate the data from whatever backing source, right? It'll be extracted from the backing source, it'll be in memory, and then your operators will be manipulating it on the fly, in general, to produce either another stream or some sort of terminal result. The intermediate operators are lazy. So if I say, hey, collection.stream.filter dot transform with a function dot, I don't know, create new stuff or do a flat map. So expand my stream or reduce my stream. Or all of those things are lazy. I can set up as many of those as I want, and nothing's going to happen until I call a terminal operator. Right, so this is somewhat useful when you're talking about patterns like strategy or some kind of algorithmic patterns where you want to sort of build them up, and you're making decisions on the fly dynamically as to what bits of the operation you want to put in place. And then you can actually, if you want, you can store that somewhere and wait for some time or send it off to some other method to actually call whatever terminal operation. Now, terminal operations are eager. As soon as you call a terminal operator on a stream, it goes all the way back up that operator call, back to whatever the underlying data source is, and then the data starts coming down through all the different transforms that you might be doing. So it sounds like it's one stream, but really you end up with a different stream at every point. And now I'm waiting for the question, how does it know how to file the chain back? I don't know. I started to look and I didn't. Yes?
So when you said all the data starts coming through, do you mean only one piece of data as you call one by one comes through, or does it?
You don't call one by, so that's the difference between an sort of an iterative approach, where you're, if you're either in a loop or you're using an iterator, or even if you're using a for each loop, you're literally saying, give me the next one, do some stuff, give me the next one, do some stuff. You don't have that kind of control with the Streams API. Unless you use a specific operator, your order isn't guaranteed, although in general with ordered backing stores, your stream will follow that order. So that's sort of just a promise. But otherwise, you don't actually know at any given time which element might be coming up. And you don't iterate in any declarative sense. Right? At no point do you say, give me the next one. The stream decides how it wants to process whatever the data is based on the input functions. Does that make sense? We'll get there. I got a whole slide. And actually, if at the end of that slide, I'll pop over to my browser somewhere and I'll show you the list of things that can come out of the terminal operators. There's a whole bunch of them.
When you say lazy, you basically are saying that when you set up this stream, nothing is happening. But once you realize the results, everything happens all at once.
Yeah, so if I say collection, and again, I'm only using collection because it's the easiest thing to think of. Collection.stream, which is there's an example of this in a second, and then say filter, and I pass filter a Lambda expression. And I can say .map, and I can pass. So filter would take a predicate, map would take a function. Right, these are all the functional interfaces from before. I could call that, I could set the I could write that expression, set that to a variable, and nothing would have actually happened. I would have constructed some sort of object, but no data would have been processed or extracted at that point. If then I call there's a dot iterator you can call at the end. We'll just hand you an iterator. At that point, whoosh, all the stuff has to happen. So all the streams you set up will actually execute at that point. I think reduce does that. I have a list. So I've kind of talked my way over my slides. But so we have some of the intermediate operators. The map operator. And by the way, these are not actually accurate. It's just annoying to keep on typing question mark extends t or super question mark tf thing, right? So I just trying to get the basic idea across. So actually, these are various types of supers and extends, but you get the idea. So the map operator takes a function called mapper. All right, so this is the single arity function. So it'll take in one element from the stream and will produce something else. That something else, or the collection of those something else's, will then be used to form the outcoming stream. So you pass in stream of type t, everything hits the function, you get out stream of type R. Filter will return the same type of stream, but it uses a predicate function. So the predicate function will simply apply some Boolean value to everything, and then the ones that fail will come out. And I should have put this in here somewhere. I don't have an example of this, so I'll just say it now. The interesting thing about, I said before, some of the functional interfaces, they do actually declare some default methods, right, even though they're single method interfaces. So predicate actually has a dot negate you can call on it. So you can set up the predicate and you call like dot negate. So you can get the opposite string. Flat map is actually really useful. It's a little bit complicated in its declaration, but what it does is it takes in a function that takes a t, so a thing of the stream that you called it on, and produces a stream of another type. So the original map, right, is a one-to-one mapping. I have an object, or I have a thing, and I produce another thing. In flat map, I have a thing and I produce a stream of things. So for instance, I have an order, and out of that order I produce a stream of order items. Right, does that make sense? And then as that process happens, all of those order item streams are resolved into one stream, and that is the return value of flat map. And then you have sorted. So I should have made a distinction here. Everything that I've said so far, before I said sorted, are stateless operators. Sorted is a stateful operator because it needs to know what happened before. It's most of the operators they'll just take the stream as they come. There are some operators like sorted that will need to know something about the information that's come before, and will have to wait for the information that comes later before it's sure that it can give you an answer. So you can either call sorted with no parameters or the one with the comparator. So either the things that you're sorting implement, right, the comparator interface, or you just hand it a comparator. And there are terminal operators. So one terminal operator that's very common is the for each terminal operator, which exists now on most collections just directly, not part of the Streams API. You call collection.forEach and hand it a consumer. And the consumer will not return anything, but it'll just do something to every item in the stream. So you can filter, you can map, and then you, I don't know, write to the database. The consumer could be the thing that writes to the database. But if you call for each, you've started whatever process it is, however much you've lined up, you'll now be doing all the execution of all your former operators. Now collect, if you look in the Java docs for collect, the things you can put in collect are like, there are like 30 things you can put in here, but generally what collect does for you is you hand it a collector, and the collector will create some other sort of thing to hand you back. The easiest and most obvious one is collectors.toList. So you would say collect collectors.toList, and then you just end up with a list of whatever it is that the last stream's type was. Remember you had like T to R, and then R could go to F, and then F could go to G. Whatever the last stream was putting out, call toList, you get a list of G. You can go do whatever you want with it. There are some collections where as long as you can create them by calling their constructor appropriately with the stuff. So you can have toCollection and you can get a tree set out of it. And then there are a handful of collectors that'll do operations depending on what type of thing you have. Generally, if you have a primitive thing, there are a handful of operations you can do. There are some, I think, on string. I thought some on date, but don't quote me on that. So if the last stream you got was an int stream, because the last transformation you did was guaranteed to produce ints, you can say summing int, and you can hand it a lambda to tell it, I lied, I just lied. Oh my gosh, I did it again. If you have an int stream, you can call summing int without anything. If you have something that has a property that will return you ints, you can call summing int with a lambda expression. So in this case, I used takes an input and then just calls .amount. And then, so in the case of orders to order items, you said summing int, order item .amount. You just get the summation of whatever orders you had. So you could have filtered on Tuesday, and then you could filter orders by Tuesday, and then flat map them to all of their order items. and then each amount you could roll up with the summing int, and it would just hand you back a number, and that's how much money you made on Tuesday, at least in terms of revenue. And then finally, like I said earlier, you can just get an iterator. It'll hand you whatever the last stream was, you get an iterator for it. Questions there? They are not by default. Stealing my last slide from me, man. Come on, don't do that. I do appreciate questions, just not ones that I'm going to answer. Well, come on. I had to cover myself. As soon as I said the object-oriented, small talk, I'm sorry. So one other thing to note about some of the operators that we have for the Streams API, some of them will short circuit. So they are good enough to know that if they don't have to keep on going, they won't. And there are actually more than this, but I just, I saw a reference to another intermediate one that would short circuit, but then I couldn't find it in the API, so I'm not sure if the dates were just off on it. Anyway, the only one I could find in the API, when I had two of them here, and I took one out because I don't know if it's a lie or not. But so limit, so you could say, okay, give me 5, right? Just like a SQL query. And so it'll just fetch the first 5 and then throw away whatever's in the stream and keep on going, so it'll short circuit there. There are a number of terminal short circuit operations, mainly that return you booleans. So you're just sort of filtering and reducing and mapping, and all you want to know is whether or not something either did or didn't happen. All right, so you have the all match or any match or none match. And so as soon as it runs into the one that either breaks or suffices the particular logic that you're after, it'll just stop and say, okay. You know, for any, it'll say, hey, you ran into one that isn't, or for all, you ran into one that is. Yes? Yeah, so if I say all match in a predicate, and I have 10,000 items coming out of my last stream, and the fourth one fails the predicate, I'm done. No, I'll just get a false and they'll be done. I'll just toss the rest of the stream.
So that gets back to the laziness, is that it's lazy, and then the terminal method determines how much work you're going to do.
Yes. And actually, I should mention, I had a slide in it, and I took it out because I couldn't satisfy myself that I had the right information. They say, and by they I mean Oracle, says that one of the reasons that the Streams API is generally lazy is that when you call a terminal operator, it will look back and say, okay, well, hold on, what were you doing here? And it will do some optimizations for you at runtime. That seems weird to me because generally they do optimizations for you at compile time. And I can see, at least in my head, how you do it at compile time. I'm not so sure at runtime, and that's why I didn't put the slide in. But they do state, they do some dynamic optimizations for you. So for instance, if you had the limit, you know, however many up, or say you had the limit at the end, but you had 4 or 5 things before it, if all those 4 or 5 things were guaranteed to do 1-for-1 output, it might only send the first n, whatever the limit function was, down the pipe in the first place. Right, so if I have 1,000 things, you said limit 100, I'll send the first 100 down. The limit satisfied, I'm done. I don't have to actually extract and do the first 3 stages to the other 900 items. Was there someone in the back?
I think I figured it out. I was trying to figure out whether the limit is applying to the thing before it, and it's basically whatever you're calling the limit on.
Yeah, right. You call the limit on some other stream. So it always starts with something.stream, then you call these operators. So limit's always called on a stream and produces a stream. So it takes the first n of that stream and gives you a stream with that many in it.
Things before that will process all the data until you get to the one that you call the limit on, I guess.
As far as I understand it, you're not guaranteed. You shouldn't be relying on any side effects of that processing. So if I said filter, filter, limit, no, that's a bad idea. If I said map, map, limit, I'm pretty much guaranteed with the map, map that both of those operators will return the same number of items in the output stream as they had in their input stream. But some of them might be null or optional. There's this optional thing. I don't know anything about it, sorry. I think, though, if I understood what I was reading about this optimization stuff they were talking about correctly, that if you said map limit, it might just say, okay, well, let me send the first n down through the first two stages. And if I haven't satisfied the limit, I'll send another one or two. All right? I'm pretty sure that's what they, but I'm only like 75% sure. I took that slide out because, like I said, some people said that's absolutely what it is, and some people said that's not what it is, and then I read a bit about it from a developer that was working on it in 2009. So I tried to do the research. I really did, I promise, but I'm not actually sure what happens. And I don't actually know how to test it. I tried to test it. It's difficult to test in a unit test because you're not guaranteed the side effect anyway. Right. Well, I tried logging it out, but the log got actually overwritten by I'm not sure what I was doing. And then I had to come here. So as an example of how to use the Streams API, let's say we have a restaurant that has a rating. So in the old world, I could say, hey, get me my good restaurants. So I pass in a list of restaurants. I declare up another array list of restaurants, the good restaurants. And then for each restaurant on my list, I check to see if its rating is over 3, and if it is, I add it, and then I return the good list. And that's sort of the traditional way of writing that. In the new hotness, right, with the Stream API, I can get good restaurants 2. I meant to take the 2 out, sorry. And it doesn't compile, obviously, if I'm doing it in Eclipse, if I don't have the 2 in there. So you return, so you say list.stream.filter, and into the filter I can pass my Lambda expression where I just say get rating is greater than 3, right? So it's parameter and expression, don't need blocks or anything. And then I call collect, and into the collect method I call collectors to list, and that will hand me back essentially the same thing. I'll get a list of restaurants out of that. And actually you don't need the return there either. I can't get out of the habit of putting return on everything in Java, even though I've been doing Ruby, which you'd think would get me out of the habit, but every time I get back, if I type a semicolon, I'm typing return. I just can't help myself. Any questions? Concurrency. This is going to be really short because I wasn't able to prove a lot of this out, but it's pretty cool. I have proved out at least that it goes faster. I've also proved out that if you're not careful about what you do to some of the things, you can have nasty side effects, just like you can in any concurrency model in any programming language in the world. So watch out for side effects. I'll just say the last part first. So by default, when you execute the streams, they'll be sequential. That is to say, it doesn't guarantee you order necessarily, but it guarantees you that you will be in sequence. So it'll go through the 100 things, and then it'll go through the next 100 things as the streams move down the pipeline. The nice thing about internal iteration, right, where you're no longer sort of handling this in loops, is that it does allow for other strategies. And the obvious strategy, and the one they built in, is execution over multiple cores. So if you want, there is a parallel stream method that will return a stream that's ready for concurrency. It makes some decisions for you, like, no, you can't, basically is the decision that it makes for you. So if there's some reason that it can't produce a safe parallel stream, and I couldn't figure out exactly what, I was able to mess up my parallel streams pretty badly, intentionally, and it didn't stop me from producing them, but it says it might. I haven't figured out why. But in this case, the stream will be split into multiple substreams, and those multiple substreams can be farmed out across the however many threads or cores you have on your system. All right, so if you have 1,000 restaurants, you could end up with that first filter being 250 restaurants in 4 substreams, and each one being filtered out for its ratings. And then the 4 output streams will be conjoined into one and sent on to the next. So it's not concurrency. I was actually kind of hoping it would be concurrency like the cool concurrency where, hey, I've already done this one. I can move on to the next operation for this one. It doesn't seem to be what it does. It just splits up at each stage into multiple processes. I couldn't figure out how. Who asked that? Something back there. Oh, there you go. weird not knowing when you turn it back around. Yeah, so you can sort of, right? Because you can give your JVM arguments that will at least restrict how much you can take up. But I didn't find anything that would let me actually control the number of threads that, at least calling. Now, of course, there's enough documentation about all this. You could write your own parallel stream. I wasn't going to do that. I mean, I like you guys, I do, but not that much. But anyway, so if you have the old one, and the whole kit and caboodle is you just call parallel stream where before you called stream. And it does. I've proved it out. Go out over multiple processors. I got 4 on mine in particular.
So to your earlier point, you were saying concurrency, I have like say 1,000 items, and it just speaks based on the number of threads, say 250 each. You're saying you pick an item, you apply a filter, and then it goes to the second one without even waiting for all the.
No, it waits. It waits. Well, this is the interesting part. So, as far as I understand it, let's say I have 1,000 restaurants, and I'm going to do my first filter, which is going to select on rating. In my case, I know for a fact it split the 1,000 restaurants into 4 substreams. I don't know if they have exactly 250, but 4 approximately 200 and something substreams, and did the filtering, and then put them back together before it went on. Nothing says that it won't start the next part of the pipeline in the case of things like predicates. There are, of course, operators that couldn't possibly start the next step unless it was going to do some compiler type stuff. It'll just start working in case that's the right answer, right? If you had a sorted operator, you couldn't start until all the streams had come back together. Oh, so you're consulting Java now? Even if it was a predicate, right? Oh, you mean if you modify the state of the object inside your operators? Right, and that object, right. So in my case, the rating. So in theory, I could have had some sort of function upstream. Well, no, I mean, so what you'd have to be doing there is I would be processing restaurant A, and in my processing of restaurant A, I would be modifying the internals of restaurant B. There's nothing preventing you from doing that? Don't. Right? I mean, well, think about it. I mean, the only way you could reference it if there was some sort of internal hook, either an internal search you could do, like so restaurants might be associated with each other. Yeah, I mean, so what you're talking about right now is exactly how I messed up on purpose, very badly, the parallelization of a test stream that I had set up, because I was curious to see when the parallel stream would not actually let me, because it says in the document at some point it might say, I'm sorry, I'm not going to hand you multiple substreams, I'm going to hand you just the one. But I couldn't figure out what triggered that. But that's the kind of stuff I was doing. I was reaching back into the collection and touching other stuff. And yeah, I mean, I don't know. Nothing says that it won't send things further on down the pipeline. It didn't appear to me that it ever did that. But without documentation. Are you typing furiously over there because you're trying to figure out if it will or won't? No. Okay, I was just curious. Yes?
Does it maintain order when it splits the streams? For instance, if your list of restaurants were already sorted alphabetically and it split it into 4 streams of 250 each?
Would it be like A through D, E through... I don't know. So if your stream is backed by an ordered collection, they will tell you that the subsequent output stream will be in that order. I didn't test it. I believe that holds true even if you use parallel streams. The one that you get out, Right. Oh, and I should mention that once you call a parallel stream, no matter how many of these I have, how many operators I have, intermediate operators, they're all parallelized, potentially at that point. All right, so each one might do it. I don't know that it will guarantee that the substreams are discrete chunks of that order. Yeah, okay, fair enough. I would have guessed no, but I didn't want to, I don't.
Usability standpoint, like most of these things MapReduce, it is like Yarn, Hadoop, all these guys implement the same things.
Yeah, MapReduce, right? It's a functional thing.
And that is capable of parallelizing that across JVMs. So I'm wondering why Java is trying to go that route when you have better opportunity with MapReduce on the Hadoop side.
But it was simple. I mean, just know how to call it.
This was not meant to be competing technology to MapReduce that you'd be able to produce with something else. This was
right. Well, and it's not certainly MapReduce either.
Functional implementation, the functional interfaces and the implementation of it.
Right. I mean, you could just map and reduce,
right,
or some combination. But there are any number of other things you could do. You don't need to reduce, right? I mean, you just map and not, well, I mean.
And the formula for the number of parallel streams you get is actually defined. Oracle puts it out. It's based on the number of cores that you have available there
right.
for text.
Yeah.
So that's how many it's going to give you. But you don't control the chunk sizes or anything like that in the default flavor.
Right. You could write your own.
And thus, you can't guarantee the order of what you've got in the streams because you don't control the chunk size.
Yeah, I mean, I assume that was the case. Like I said, I know that when you have the ordered collection behind you, the streams that you get all the way down the line are in that order, and it appears to me that when those streams come back together, they're in that order.
Well, yeah, but if you process in parallel, you cannot guarantee that they come together in the right order.
Oh, no, certainly not. I mean, I'm not, definitely not in terms of the racing conditions, like whether or not this guy will be executed. Like if I have A through D over here and, Q through Z over here, I have no idea if AC will be done before Q, whatever. I mean, no, right, not that. I just don't know if when they split the streams, if they take them in ordered chunks. That is, they say, okay, I'm going to take the first order and make that, so like if there are 1,000, 1 through 250 goes there, 251 through 5 goes. Do you know the answer to that? I don't know the answer to that. Okay. But yes, definitely they're definitely racing each other, and there's no control, absolutely no control over who gets done when. No, you don't. Well, parallel stream, yes, and stream, yes. You could call. There's a method there's an operator on stream called parallel. You can call. I guess if you know that at some point you don't want to be parallel, and then you want to be parallel, like if you're doing something crazy, like reaching back and touching the restaurants at someone else's process. I'm looking at you, man.
So the comment before about why, they are getting us ready to run multi-cores on everything.
Yeah.
Today, you guys, we all think about basically linear programming with most objects. Mm-hmm. They're trying to get us all to the point where we're taking advantage of all the cores. I mean, look at your phone. You have more power in your phone than you had computers 5 years ago.
Sure.
This is a way to start us all thinking about parallelization.
Yeah, I mean, I think in general the 4th gen and higher languages are all looking towards parallelization, mainly because Moore's law is slowing down. I mean, we don't have it's not right. Clock speed is slowing down. You're still getting more transistors on a chip. You're just getting them further apart from each other, so they can't talk as fast. That's why you have cores, right? So, I mean, you're going to run into a clock speed limit. If you want to keep on going faster and faster, we're going to start running into clock speed limitations. And the answer to that is to make your code as parallelizable as possible. So Java, and I mean, that's what Clojure is for, right? I mean, Clojure was built mainly so you could write code that could just run wherever it wanted. Anything else? So I'm done, by the way, so if you have any other questions.
Yeah, maybe a stupid question, but when, talking about streams, and there's some similarities over to I/O streams, right? So where you could basically layer different streams. However, I use streams in the past at some point to let's say, you layer, use different streams to like read stuff, then you zip it up, then you do encryption, etc. Basically, really nice to reduce memory footprint. However, it's pretty painful to work with that in a more detailed manner. Is there possibly a way to use the stream API for even file input-output type of scenarios?
Yeah, so the streams here, I mean, I've been talking in terms of collections because it's really just the way I was sort of thinking about it when I started looking into them. But they can certainly be backed by file I/O. So you can essentially read either characters or lines off a file or out of memory or across a socket. And you can use a stream API on all of that all the way through. Yeah.
In that case, like I have named only
Yeah, you can serialize the stuff, man. Go ahead. Fork the stuff. Build your own. Implement serializable. There's no reason you can't. What are you going to serialize? I'm just curious. You're really excited.
No, I was talking about that you could, maybe this is kind of like a continuation where you could serialize an object, put it over a port, deserialize it. I mean, a stream could, you could take a collection, serialize that over a port, and then on the receiving side, take that streams that
right. On one side, you could yeah. Yes. Well, actually, what you could probably do, I think you would have to. I don't think they implement serializable in most of the functional interfaces, because I didn't see it. I mean, maybe it's in the hierarchy somewhere. But there's no reason you couldn't override them to do that, right? Because they're all anonymous well, they're all anonymous. They're all instances, right? And fairly simple ones that hold very little data. So as long as the could you? That's interesting. I wonder, right? Because if you're using a Lambda expression and not a method invocation, could you, if you didn't have the declaration of the Lambda expression on the other side of the socket, even when you deserialized, what would you be deserializing into? Where's the definition of that object?
Well, I'm saying that let's say you have a list of maps, and you decided that part of your processing is going to be here on the network, and part of your processing is good here. Could you take that and serialize, and then you're not transferring your functional part. You're processing. You have a map, okay, and unless I'm missing something here, that those objects in that map would have to, you'd have to extend something to produce a functional filter. Seems like no, you wouldn't. That you're defining.
Right, you have to call stream on the map.
Right.
And then you get that starts the intermediate streams.
Well, I'm actually saying that you're calling stream on a socket. And then now you've got this stream of bytes, and now the question is, can you change that, can you deserialize that stream of bytes into a stream of objects?
You should be able to.
Yeah, I think so.
You should be able to actually, I mean, in Hadoop or Cassandra, they use the same concept, but they don't use, they chose not to use the Java serialization and deserialization, primarily because they say it is not the best of, I mean, the performance difference. Yeah, performance difference in Java serialization and deserialization is too much, so they decided not to use it. And they have come up with their own.
Yeah, I mean, it seems like you should be able to do it. Oh, and before Randy gets mad at me. I'm supposed to do this thing. Where's the play button on PowerPoint?
It's third icon.
Oh, this one. So I'm from ThoughtWorks. I'm supposed to do the marketing thing. It'll be like 2 minutes, I promise you. We have global reach and global insight. No, seriously. ThoughtWorks is a 20-year-old IT consultancy. We were born in Chicago out of someone's idea that maybe you could just hire a bunch of really good developers and solve people's interesting problems and go around the world and do that. That was in '96, and right now we're in 27 countries and 5 cities in the US. One of them's right here in Atlanta. Our office is down on 14th and Peachtree. We host the Software Craftsmanship Meetup and some other meetups too. What else do we host in the office these days, Randy? Do you know? Yeah, see, I called him out. I don't know either. But Software Craftsmanship, you can find that on meetup.com. We've been thinking deep thoughts for 20 years. We write books and stuff, and we contribute to all sorts of open source things, and we're always hiring. So, you know, if you know anyone who's like a good developer, I mean, just saying. Thank you.